Now, some of you might have noticed already, we have a problem. How is that going to look highlighted in yellow? That's going to look awful. Okay, and you're not going to miss that. Okay, so we have a problem here. And the problem is that we're modifying the model matrix. Our transforms, our functions, we modified this matrix. Okay? It actually turns into a big mess very, very quickly. A function can break any other function that calls it if it messes up the matrix. Right? If you break the matrix, you can break any other code that calls it. Okay. Let me highlight this. I'm going to use maybe a small red highlighter. So let's go back to where we were at the top. Okay, we have draw flower bed here. Draw flower bed assumes a happy matrix. I'm modifying the matrix here. And then I draw flower. I don't know what draw flower does. I don't know what it does to my matrix. So how do I calculate this translate in this scale without knowing what happens inside draw flower? It's impossible. Okay? I have to assume that draw flower doesn't break anything for me. Even, I also want to highlight that here, these are dependent on each other, right? I have to undo that scale, undo that translate, or I have to make my second one with awareness of the first. It's messy, it's hard to do, okay? And this is in draw flower bed. Then inside draw flower, look what I'm doing. Rotate, scale, right? I'm modifying, translate, rotate. And then when all of this compounds my model matrix, and when I return to here, boy, that's a mess. I need to undo everything, okay? So this is a good idea, but we have one more problem to solve. This is a management problem. Now the most common solution is a simple rule. And if everybody follows this simple rule, the problem goes away. The rule is this. If we modify the matrix, we need to restore it when we're done. We restore it to its previous state, or when we're done, right? So back up here, draw flower, we should here restore the matrix back to where it was. And then if we do that, then in draw flower bed, calling draw flower won't matter because it restored the matrix. It didn't mess up our matrix. So if we can follow that rule, we back up the matrix before modifying it into a variable or something, right? And then we put it back to where it was before we're done, then we're good to go. That problem goes away. Now there's a lot of ways you can do this, and it actually turns out to be messier than you expect, especially if you're using a lot of stack variables. It uses a lot of memory, you're copying in this. So there's actually a standardized way to manage this that's very common in graphics systems, and it's certainly the standard in the OpenGL immediate mode that we're learning. And this is a matrix stack. We use a matrix stack to solve this problem. So we incorporate a stack. So we can save and reload our matrix. Saving the matrix easily. So stacks are great. First of all, if we have some stack memory already saved, we can add and remove from the stack much quicker than allocating new memory, right? Or doing our own copy. It's centralized, So this is a simpler implementation, okay? But there's other benefits as well. First of all, the stack remembers the order that the matrix was saved in. And this is great, okay? Because this naturally supports recursion. It naturally supports nested function calls. If I save it in higher level, you call a subfunction which saves it, another subfunction saves it. As long as everyone restores on the way back out, the order is saved. So this naturally supports recursion and nested function calls. You don't have to worry about that. Okay. So this matrix, as you can imagine, is really simple to use. And the way we use it is, again, really simple. We push to save the matrix, and we pop to restore the matrix. It's that simple. And remember, I'm repeating this, the rule is always leave the matrix in the state you found it in. And if you do that, the problems go away. About the problems we mentioned earlier. And this enables others to call your code and just put transformations in front of you, right? So others can call your code and use your code, and your code won't break the caller. So others call your code. You don't break the caller. Okay, so let's look at this. Let's look at an example of how to use this. How do we use it? So I'm going to keep going over our previous example. Draw a flower bed as our function. Now the first thing we're going to do is push matrix. So we save it. I really should be using blue for code. It's no big deal. So we can save it, right? Good. We save the matrix. We can always come back to it. And then I'm going to translate scale, for example, resize. I'll rotate, I mean. Scale is resize. And I'm going to draw my box. So I've figured out this calculation. I want to use it to draw my box. Actually, I should move that a little bit more to the side. Yeah. So that's my coordinate system. And then I did that. I draw my box. Fantastic. Good. But now that I've done that, I can just go back to calling pop. I can go back to where I was. Pop matrix. I'm done that. I want to go back to my origin. Right? Reset to origin. So I go back to where I started, back to my origin, so I'm at 0, 0. I undo all that, so I don't have to worry about the next one down the list, okay? Now, of course, as I said earlier, reverse order, right? Okay. But now that I'm using this matrix, it really simplifies things. I solve this box, I'm done. Now, I'm going to push the matrix again before modifying it. I'm going to translate scale draw flower. So I'm going to make this draw the flower at its origin. I'm going to scale it up and then translate it somewhere in my scene, right? Like here. And if I trust this to reset the matrix, then I don't have to worry about this, right? I don't have to worry if I want to draw something after it. In this case, it doesn't matter anyway because I'm done. I'm going to pop my matrix. Okay? And then I'm going to do it again. Push, matrix, I'm going to translate, scale, draw flower, and I'll get the other flower because I changed my parameters. Now, I'm sure many of you are looking at this and going, well, that's a lot of pushing and popping you might not need. And you're right. You might look at optimization later and go, okay, where can I be a little more clever with what I'm translating and scaling? Like maybe I could leverage the previous scale, and you can start thinking about that. But that's really micromanagement. You don't want to be thinking about this at this point. And while I'm at it, I'm going to break this out and say, look, if we look inside draw flower, it does the same thing. The first thing it does is it pushes the matrix, right? It saves it. And it's assuming it's drawing around its own origin. Of course it's not, because we've modified the matrix ahead of it, but it doesn't know that. It doesn't need to. We draw the stem, right? Then we translate. We draw the center, so we modify the matrix all the way. But we don't care. Draw 6 petals with a for loop, for example. We do all of that with rotates in there, and we just pop the matrix when we're done. Pop, bam, we're back. We didn't have the people who call us don't have to worry about what we did with the matrix. In all of these cases, oops, I made the mistake. Pop matrix. Right? In all of these cases, we leave the matrix in the state we found it. Okay? So now you might want to think about this. How would you add a third smaller flower? Right? Think about that on your own. A third smaller flower, okay? And hopefully if you think about it, you can find an easy way to do it. So, a couple of things I want to highlight here. Note, we don't usually start at the identity. If we start at the identity, then someone won't be able to modify or translate or rotate before calling our function. Okay, so we don't start at the identity. We usually trust what's on there, trust what's on the matrix already. And this enables people to call us. On the matrix. That way people can modify the matrix before calling us, and then they can position us and modify the scene. So this enables the caller to transform before calling our function. Okay, so you can imagine at the very top level then, you might use it like this. Load identity matrix, and then you do your translate, then you do your scale, and then you draw the flower box. Because you might want to draw it a little differently, right? So this resets the matrix, and we move it, make it bigger, and draw it differently. We have this freedom now. So this whole approach of hierarchical modeling really simplifies the coding problem, okay? You break your object into some hierarchy, you draw each component without worrying about how it was used. You let the calling function do transforms before calling you to position, scale, and rotate you, and then use the matrix stack to manage your state. So this really simplifies the problem. Okay, that's hierarchical modeling.